So the last thing that I really wanted to talk a little bit about was proofs with you, because I think proofs are difficult for all students. So what I did here was I just listing out kind of the steps I take when I'm going to solve a proof, and then we'll do an example. And then you can use this YouTube video anytime you have a proof and you want to go through it. So the first thing I do is I draw a figure that illustrates what's supposed to be proved. And sometimes that figure's drawn for you, but if it's not, I'll just give you this example. So this example says that it's given that segment AD bisects segment BC. So I would draw a segment, and I would label it AD. And let's see. Then I would draw another segment, and I would label it BC. So then I would, if I didn't know what the definition of bisects means, I would maybe look that up somewhere. Like maybe Google it, bisects. So what does it mean to bisect? And then I see in here, in geometry, it means dividing something into two equal parts. So two equal parts. That tells me if AD bisects BC, that tells me, despite my not such a great picture, that this length is exactly the same as this length. Okay. Then the other thing that's given is that segment BC bisects segment AD, which tells me this length is the same exact length as this length. So I have two equal lengths. Now I'm supposed to prove that triangles, so I'm going to have to make more segments here because I have to make them into triangles. Triangle ABM. So I'm just going to call this angle in the center angle M. Let's do M. So I'm going to draw on those triangles now. Let's do that with a different color. So triangle ABM it is congruent to triangle DCM, and actually these, let's just make it the same. So AB, I'm going to put a little arrow on this. Oops, I want to put it the other way. I'm going to put an arrow on this because I want to show which direction those we're going. So it's ABM. So that triangle is congruent to triangle DCM. So this one is actually going the other way. So this triangle is going this way. So ABM is congruent to triangle DCM. So basically, I'm going to have to, at some point, show something about this angle and this angle maybe being, equal or something, because they're the corresponding angles. That's the way that they appear in the proof part. So usually when you're doing a proof, let's go back to the steps. So the second step that I do is I list the given statements and list the conclusion to be proved, because then at least I have something in my proof here. So I'm going to go back down here, and I am going to, I don't like that line. I'm going to use that. All right. Okay. So I'm going to go back up here. I'm going to list the givens and what I need to prove. So the first thing that's given is AD bisects BC. And the second thing that's given is that BC bisects AD. And then I'm going to give the reason for both of those, which is given. And then the very last thing that I have to prove in the end is that triangle ABM is congruent to, well, I should put the congruency symbol, is congruent to triangle DCM. So I'm just taking that right from what they said, and I don't know what I'm going to use to prove that, but eventually I have to prove it. Okay, the next thing I do is I start, making the figure and looking at it in a way that's going to help me get to that conclusion. So I'm going to look at what I do know. So there are some things that I do know, and I'm going to start with AD bisects BC. The fact that AD bisects BC tells me that BM and MC, or BM and CM, are the same length. So I can say, BM is congruent or the same exact length as CM. And the reason I know that is because I looked up the definition of bisects. It told me that. Then I can also say that AM is congruent or is equal to DM, and it's for the same exact reason, because of the definition of bisects. All right, so that might come in handy. I also happen to know that because of vertical angles, angle M or angle AMB is congruent to CMD, and that's because I know something about vertical angles. So I'm going to put that in there. AMB is congruent to AMB is congruent to DMC, and that's because of vertical angles. They're kitty corner from each other. Then I see I have a side, an angle, and a side. That's the same as a side, the angle, and the side of the next triangle. So I can say that AMB is congruent to DMC because of side, angle, side.